Okay, so what we're going to be working on today is determining whether or not a function is even or odd. So I want you to try to recall from last year from geometry when you guys did transformations, a rotation of 180 degrees, which we're going to talk about right over here, and a reflection in the y-axis, which is right here. So hopefully you remember when you reflect something over the y-axis, it's a mirror image. So the rule, hopefully remember, is when you have x, y, the rule for reflection over the y-axis is xy becomes negative x, positive y. Okay? So if I have 3, 5, 3, 5 will become negative 3, comma 5. So let's just take a look at this now. Notice the x values. Look at the x values here. The x values are opposite. And look at the y values. My y values are the same. All right, so remember when you have a reflection over the y-axis, so I'm just going to do a quick graph of this, 3, 5. So there's 3, 5. And when I reflect over the y-axis and I get negative 3, 5, that's over here, the points are symmetrical to the y-axis. It's a mirror image. So that's something that we have to remember. So this is symmetrical to the y-axis. Okay? And let's just take a look over here at the rotation of 180 degrees. So remember, the rotation of 180 degrees would be when you took your paper and you turned it upside down. So if you remember what the rule is, hopefully you do, xy becomes negative x, negative y. So 3, 5 becomes negative 3, negative 5. So notice that the x values are opposite, but so are the y values. The y values are also opposite. So on the graph, if we look at this graph quickly, 1, 2, 3, 1, 2, 3, 4, 5. So here's 3, 5, and then we have negative 3, negative 5, which would be right over here. Okay, so that's actually a rotation. It's a turn of 180 degrees. So if I took my paper and I turned it upside down, where my point starts when I turn my paper upside down, it's actually in this blue point is in the same place. It'll be now in quadrant 1, okay, at 3, 5. Okay, so over here, just some quick notes over here. Okay, so we have a even function is a reflection over the y-axis. So the rule is xy becomes negative x, comma y. And therefore, the graph is symmetrical to the y-axis. And then we have our odd function. Our odd function is the rotation of 180 degrees. So xy becomes negative x, negative y. All right, so now how do we determine if a function is even or odd? So the first thing you're going to do, so step 1, is find f of x. Now what you're going to do is you're going to pick a number. So you pick a number. You're going to pick a number for x. And then what you're going to do is find f of negative x. So notice that what I have up here is x and this is negative x. So they have to be opposites. So whatever you plugged in for x over here, you have to do opposite of that. You have to do the inverse. Okay, so you have to plug in opposite the x value you plugged in for number 1. Okay, so let's take a look over here. Let's try that now. All right, so I have f of x is equal to x squared plus 4x minus 5. So I want to determine whether it's odd, even, neither, and then I want to determine and just state why. Your y's are going to be symmetrical to the y-axis or a rotation of 180 degrees. You could also say reflection over the y-axis. All right, so let's start with f of. Now we're going to pick a number. I'm going to pick 2. Why 2? Why not 2? All right, so I'm going to plug in 2 for each x value. So I have 2 squared plus 4 times 2 minus 5. Now you could plug that right into your calculator, and what you get is 6. Now you have to do that same number 2, but opposite of that. So f of negative 2. And you're going to plug that in. Negative 2 squared plus 4 times negative 2 minus 5, and you get negative 9. Now, what do you notice about these? They are different. Okay, so now we want to be able to show this algebraically. So what I'm going to do, so we did it using a number here. So now I'm just going to rewrite this. F of x is equal to x squared plus 4x minus 5. Okay, and now, so I have my x value. My input here is x. My output here is my y. So now I want to do f of negative x, right? I'm going to plug in my negative x value, right? Just like I had x here. It's my x. Now I'm going to plug in negative x, negative x. So I plug it into the equation. So wherever I see an x now, I'm going to plug in negative x. So it's negative x squared plus 4 times negative x minus 5. All right, so I have f of negative x is equal to negative x squared is positive x squared. 4 times negative x is negative 4x. And then I have minus 5. So are they the same, opposite, or are they different? So let's take, I had here positive x squared. It's still positive x squared. So those are the same. I have 4x, positive 4x, negative 4x, but now those are different. And then it's negative 5 and negative 5. So only the middle here, the ends are the same, but the middle is opposite. So this is neither, because it either has to be, the whole thing has to be the same, then it's even. If the whole thing is opposite, then it's odd. So these are different. Okay, so what we're going to write, since they're different, is that it's neither even or odd. And then we're going to write a reason. So I'm just going to move everything up a tiny bit. Okay, so this is neither. So neither even or odd, because it is not symmetric to the y-axis, and it is not a rotation of 180 degrees, and that's the word not in there. Okay, so just quick review before we go back onto the back page. If the results when you plug in are the same, if they're equal, then it's an even function. And when it's an even function, remember, it's a symmetric. This one's symmetric to the y-axis. If you plug in your x's and you get opposites are odd. That means it's a rotation of 180 degrees. If you plug in opposite x's and you get neither one, equal or opposites, it's neither symmetric to the y-axis or rotation, which is what we had right over here. So let's flip it over. Okay, so let's take a look at number 2. So I have here that f of x is equal to 8x to the second minus 2x to the fourth. All right, so we're going to start with f of, just pick any number. I'm going to pick f of 3. Okay, so f of 3 is equal to 8 times 3 squared minus 2 times 3 to the fourth. Just plug it into your calculator. You get negative 90. Now we're going to do f of negative 3. So it's 8 times negative 3 squared minus 2 times negative 3 to the fourth power. Plug it into your calculator. and you also get negative 90. So what do we notice about these? These are equal. Equal means even. All right, so now I want to also, before I write, why it's even, I want to do it algebraically. So first I'm going to rewrite the function. F of x equals 8x squared minus 2x to the fourth. Now I want to do f of negative x. So wherever I see an x, I'm going to plug in negative x. So it's 8 times negative x squared minus 2 times negative x to the fourth power. So this becomes f of negative x is equal to negative x to the second power is going to be positive x. So it's 8x squared minus, so I have negative x to the fourth power, right? This right here, negative x to the fourth power is going to be positive. Any negatives to raise to an even power is always positive. So that's going to be 2x to the fourth power. So notice I started off with positive 8x squared. It's still positive 8x squared. Negative 2x to the fourth, negative 2x to the fourth. So when I plugged in x, plugged in negative x, I get the same exact thing. That would mean that it's equal. And equal means even. So now we're going to write, it's even because, so let's write even because, and then you write it is symmetrical to the y-axis. Okay, let's look at the next one. I know your number 3 is nice and typed. I had to redo mine, so just bear with that. Okay, so I have f of x is equal to x to the third times x minus 2 times x plus 2. So pick a number. I'm going to pick 4 this time. So I have f of 4 is equal to 4 cubed times 4 minus 2 times 4 plus 2. Okay, so you're going to plug that into your calculator. So put me on pause so you can plug it in. You have to be able to do this on your own. And come back. So you get 768. Now we're going to do f of negative 4. So it's negative 4 to the third power times negative 4 minus 2 times negative 4 plus 2. And you get, plug it into your calculator, negative 768. So what do you notice about these? These are opposites. So opposites means that it's odd. Opposites odd. Now we want to be able to do it algebraically. So let me rewrite the function. F of x equals x to the third times x minus 2 times x plus 2. Now I want to do opposite my x. So I'm going to do f of negative x. Wherever I see an x, I plug in negative x. So it's negative x to the third times negative x minus 2 times negative x plus 2. Okay, so I get here f of negative x is equal to negative x to the third power is still negative x to the third. And then I have here times negative x minus 2, which is just negative x minus 2, and then negative x plus 2. Okay, so notice these are opposites, right? So I have positive x to the third, negative x to the third. X minus 2, positive x minus 2. Look here, I have negative x plus 2. X plus 2, negative x minus 2. These are opposites. So let's write that down. Opposites. Oops. Opposites. So it's odd. Okay, so we're going to write an odd function because it is a rotation of 180 degrees. Okay, so I'm just going to move everything up and we'll try the last one. Okay, so last one we have f of x is equal to x times x minus 2 squared times x plus 2 squared. All right, so let's pick a number. I'm going to pick 2, f of 2. So it's 2 times 2 minus 2 squared times 2 plus 2 squared. So plug that in your calculator, so put it on pause, plug it in. You get 0. So now we're going to do f of negative 2. So it's negative 2 times negative 2 minus 2 squared times negative 2 plus 2 squared. Use your calculator, plug it in, and you get 0. So what are these? These are the same. They are equal. Equal is even. All right, now we're going to do it algebraically. So I'm going to rewrite the function. X times x minus 2 squared times x plus 2 squared. And now we're going to do the opposite, f of negative x. So wherever I see an x, I plug in negative. So it's negative x times negative x minus 2 squared times negative x plus 2 squared. There's nothing to simplify here, so let's see what we have. So I had x, now it's negative x. I have x minus 2. Okay, so I have x minus 2 here, right, squared. Now over here, look here. So I have negative x minus 2, but because it is square, it's going to end up squaring this, and it's going to make it positive. Just like when I square this here, it'll end up making it positive when I double distribute. So this is going to be positive, and this will still be the same then. Right, and then the same thing here. When I square this and double distribute, this will be positive, and when I double distribute here, that's going to also be positive. So these are actually the same. They're not opposites. These are the same. So these are equal. Equal is even. And we write it's an even function. Because it is symmetrical to the y-axis. Okay, so that's it, and we'll practice more in class tomorrow. Have a good day.